Hi, I'm M. Nandini, Assistant Professor, Head of Department of EEE, TPGIT. In this video, we are going to study about what is transducers, function of the transducers, various types of the transducers, and some selection factors of the transducers. Before going to enter into the topic, first we want to know how transducers are important for any instrumentation system. Here this is the basic block diagram of an instrument system. Here the first element is the primary sensing element. The primary sensing element receives our input signal, that is measurement or quantity to be measured is received by using a primary sensing element. After receiving the signal, various processes are done to get our desired output or acceptable output. After getting the acceptable output, the data can be stored or displayed by using a data storage device or displayed device. Here the measurement receives in the form of non-electrical parameters, that is most of the signals we want to measure is a non-electrical in nature, that is the pressure, temperature, humidity, force, displacement. So by using that non-electrical quantities, we can do some process. So here the problem occurs how the non-electrical quantity is converted into the electrical quantity, because nowadays the most technologies or most methods are in electrical methods. So we want to convert our non-electrical quantity into electrical quantity. For that the device was developed to convert our non-electrical quantity into the electrical quantity is called transducer. So transducer is a device which is used to convert our non-electrical parameters, that is the pressure, temperature, humidity, displacement, into the electrical quantities like a voltage, current, frequency, resistance, capacitance, etc. In other words, a transducer is also called, it converts energy from one form to the another form. So next we are going to discuss about basic block diagram of a transducer. It mainly consists of two parts. So first part is the sensing part and second is the transduction part. So first in the sensing part, they have a sensors. The sensors just sense the non-electrical quantity. After sensing the signal, the output is given to the transduction element. The transduction element converts our non-electrical quantity into electrical quantities like a voltage, current, or frequency. There is a difference between transducers and sensors. All transducers are called sensors, but all sensors are not a transducer, because sensor just receives a signal and it gives the output. In case of transducers, it also receives the signal and it converts the signal from one form to the another form. So next we are going to see about various classification of the transducers. So first type is the active and passive transducers. And second is the primary and secondary transducer. Third is on the basis of transduction principle. Fourth is transducers and inverse transducers. And fifth is the analog and digital transducers. So first we see about what is active and passive transducers. So active transducers. These transducers don't need any external source or power for their operation. Operation means it does not need any external source to convert non-electrical parameters into the electrical parameters. So active transducers is also called as a self-generating type transducers. Example of a active transducer is a thermocouple. Here thermocouple is used to measure voltage based upon the temperature. Based upon the temperature, the voltage can be varied. In a piezoelectric transducer, by using a piezoelectric crystals, when we are applied force on the axis of the crystal, we can able to measure voltage at the edge of the crystals. So next is the passive transducers. For a passive transducer, they need external power or source for their conversion, that is the for converting physical quantity into the electrical quantity, they need any external source. The external source may be a DC power supply, or audio frequency generator or AC power supply. So example for this is LVDT, that is linear variable differential transducers, or thermistor. In a linear variable differential transducers, if you are giving a displacement as output, we get a AC signal, that is AC voltage signal as a output. In a thermistor, according to the temperature change, the resistance is going to be changed. So next classification is the primary and secondary transducers. In some of the cases, two transducers are combined together to get our desired output. Here, in most of the cases, primary transducer is a mechanical transducer. In a mechanical transducer means the output is in any non-electrical quantity. That non-electrical quantity is converted into mechanical signal, that is displacement or force. So after that, that mechanical signal is given as a input for electrical transducers, that is a secondary transducers. Then that mechanical signal is converted into the any electrical signal. So the best example of primary and secondary transducers are Bourdon tube. Here the Bourdon tube is act as a mechanical transducer, that is a primary transducer. Here the LVDT is act as a secondary transducer or electrical transducer. Here the pressure is given to the input for Bourdon tube. By using that pressure, it converted that pressure into the displacement. After getting the output from a Bourdon tube, that displacement is given to the core of the LVDT. That displacement moved the core of the LVDT. The movement of the core induces the output voltage, which is directly proportional to the displacement of the tube. So next we are going to discuss about next type, that is according to the transduction principle. So what we get output is called according to the transduction principle. If you are getting output in a capacitance, means that is called the capacitive transducers. Second is the resistive, and third is the inductive transducer. In a capacitive transducers, we know that when two plates are separated by a dielectric medium, it forms a capacitance. When we are the two plates, one plate is a movable plate. If you are applying a force to the movable plate, definitely the distance between a movable plate is going to be changed. If any, we already know the formula that C is equal to epsilon A by D. If distance between the two plates are changed, definitely the capacitance of the material is going to be changed. So we get a output as capacitance. So next type is the resistive transducer. Here we get output in terms of resistance. The example of the resistive transducer is a strain gauge, whose resistance varies with the applied force. Here it converts, that strain gauge converts a force, pressure or tension into a resistance. So next is the inductive transducer. Inductive transducer is in which the self or mutual inductance are varied when excited by an external source. The example of the inductive transducer is LVDT, that is linear variable differential transducer or transformer. So next classification is the transducers and inverse transducers. We already discussed that transducer is a device which is used to convert our non-electrical quantity into the electrical quantity. The inverse transducer is vice versa, that is the electrical quantity is converted into the non-electrical quantity. Here the best example for both the transducers and inverse transducer is the piezoelectric transducer. In a piezoelectric transducers, first the pressure or a force applied between the axis of the piezoelectric crystal and the edges of the crystal, we can able to measure the voltage, that is called transducers. In an inverse transducer, if you are applying on the edges, if you are applying electrical signals or voltage on the edges of the crystal. Uh, at the axis, the dimension of the crystal is going to be changed. The only one crystal is suitable for both transducers and inverse transducers or piezoelectric transducers. So next classification is analog and digital transducers. In analog transducers, we get a output in analog form. The example for analog transducer is LVDT. Next is the digital transducers. In digital transducer means we get output in the form of pulses or zeros and ones. The example for digital transducer is optical encoder. A digital tachometer or the example of digital transducer. So next we are going to discuss about how we are going to select the transducers, because out of various transducers are available in the market, out of which how we want to select our transducers. So first, based on the principles of operation, depending upon our application, whether it is a capacitive or resistive or inductive, our transducer is chosen. So first selection criteria is depending on principles of operation. So next is the availability. So availability, whether the chosen transducer is available in a market, source of location, whether it is a portable or not, that is comes under the availability. So next is the cost. Of course, cost is very important for any transducers. So next is the performance figure. In a performance figure, we are going to measure the characteristics of the transducers which we want to purchase. The characteristics of the transducers measures the response time, recovery time, sensitivity, whether our chosen transducer is sensitive or not, and next is the input operating range of the transducers. All these comes under the performance of the figures. On the basis of the above, we can choose our transducers for our applications. In this video, we discussed about what is transducers, function of the transducers, and various classification of the transducers, and some selection factors to choose how we want to choose our transducers. In next video, we are discussed about LVDT, thermistor, and piezoelectric transducer. I hope this video is helpful for your study. Thank you for watching my video.